Let us return to the problem that we started with in the launch for this week. What did we do there? We solved linear systems, but the linear systems had a very special form. They involved a triangular matrix. It happened to be an upper triangular matrix. Now, let's think this through. We've just learned that the condition number of a matrix determines how, in the worst case, a relative error on the right-hand side can be amplified into a relative error in the solution. And we've hinted at the fact that the condition number is bad if a matrix is almost singular. Now, how did we create our triangular matrix? We created it with random numbers. All right? So, if you're unlucky and you place a 0 on the diagonal, then you would end up with a singular matrix, and that would obviously be really bad. You can conjecture that if an element on the diagonal is nearly 0, that then your matrix is nearly singular, and that therefore the condition number of the matrix is very large. Okay? And in that case, a small relative error in the right-hand side may end up being amplified into a huge error in your solution vector. Okay? And of course, if your matrix is small, it's a 3 by 3, then the chance of an element on the diagonal being 0 or nearly 0 is small. As you increase your matrix size, the chance increases greatly. And therefore we saw that when we went to a 100 by 100 matrix or some other larger matrix, all of a sudden the whole process fell apart. And it merely had to do with how we constructed the matrix with which we computed. It had nothing to do with there being an error in the routine that MATLAB supplies to solve linear systems.